Hi all! Today I will discuss a curious integral, the integral of 1 over x squared from -2 to 3. On the screen you see the graph of the function and the area this integral represents. Let's do the calculation. Do you remember the antiderivative of 1 over x squared? 1 over x squared is x to the power -2, so an antiderivative is 1 over -1 times x to the power -1, which is -1 over x. Thus, we see that the integral from -2 to 3, 1 over x squared equals, plug in the upper limit -1/3, minus, plug in the lower limit -1 over -2, which equals -5 over 6. Thus the area in the picture equals -5 over 6. That was not so hard, was it? Wait. The area is clearly above the x-axis. That's positive. So the value can't equal -5 over 6. Something must be off. You might think I just missed a minus sign somewhere, but if you check the calculation carefully, you'll find that there are no errors there. So what's up? If you go back to the picture of the graph, you'll notice that I did not draw the entire area, as the function becomes too big near the origin to draw. Indeed, near x equals 0, the function 1 over x squared becomes infinitely large, and at x equals 0, it does not even exist. We say that x equals 0 is an improper point of this integral, and that the integral of 1 over x squared from -2 to 3 is an improper integral. Another kind of improper integral arises if one of the limits of the integral is plus or minus infinity. Consider 1 over x cubed from 1 to infinity. The area under the graph is very thin but infinitely wide, and it is unclear what it should be. Let's be bold and just do the calculation. An antiderivative of 1 over x cubed is -1 over 2x squared. So the integral of 1 over x cubed from 1 to infinity is -1 over 2x squared between 1 and infinity. I know what happens if I plug in x equals 1. But how can I plug in x equals infinity? Well, infinity is not a number, so we can't calculate it like this. The proper way of dealing with this is to take a limit to infinity. Thus the integral from 1 to infinity is the limit of the integral from 1 to t as t goes to infinity. The integral itself is now an integral over a finite interval, just as we're used to, and can be readily calculated. It is shown to equal -1 over 2x squared between 1 and t, that is, -1 over 2t squared plus a half. Taking the limit as t goes to infinity, the -1 over 2t squared term becomes 0, and the final result is a half. The orange triangle on the slide has area 1/2 as well, and it is not a stretch to imagine the yellow area being equal to the area of this triangle. We have now seen two types of improper integrals. If either plus or minus infinity is the limit of an integral, we say the integral is improper of the first kind. If the function you integrate is not continuous at some point in the domain, or on one of the endpoints of the domain, as in the first example of this video, the integral is improper of the second kind. In class, you will learn how to write these improper integrals as limits of integrals without improper points. This works both for improper integrals of the first as those of the second kind. Goodbye!